Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on Twitch. We do not use any engines or libraries here. The only thing that we use is the platform that we're forced to run on top of, which today is Windows. What are you going to do? That's what you got to ship games on these days. So that's what we use, but other than that, it's all our own code, and we show basically how to do absolutely everything. We don't even use the GPU. We actually did all of the rendering ourselves. Write down every little pixel is something that we put there and thought about how it was supposed to work. So we're in pretty good shape right now. We've done a bunch of the stuff that we need to do to get ourselves into the state of having an engine. And I don't know, today I'm just kind of, I don't ever, I've said this multiple times on Handmade Hero, I don't really ever feel the need to try to stick to any kind of schedule, because I find that programming works best when you are, when you tackle whatever is the most logical problem at any given time. And so I'm not sure exactly what we're going to do today, but I think we may do something that we weren't supposed to do or something like that. I'm just getting that feeling, so that's probably what's going to happen. Anyway, if you'd like to follow along, today is day 132, so unpack day 131 source code from the zip if you have pre-ordered the game. That is the source code that I am working with, and if you would like to follow along at home, that is what you should use. Yesterday, we did a little bit of work to get ourselves background computation for graphics resources and stuff like this, and so as you saw yesterday, we now don't have problems with hiccups when we recompute background graphics, so that's always good. And to a large extent, that means we pretty much are stall-free now, but there is a little bit of sort of a hidden stall in there that we haven't really addressed yet, and that is sort of asset loading. You can see that when we are starting up the game, we actually load all of the bitmaps when we, let's see here, load bitmap. You can see in here that we actually load all the bitmaps manually because we haven't really ever thought about what we want to do as far as that's concerned. And we did have a thing on here that's like got asset streaming as a thing. And I don't know. We made some thread stuff. I feel like we might as well just go for it. Why not just say this? Asset streaming is incredibly trivial. There's almost nothing to it. It's extraordinarily simple. You've already seen me do almost absolutely everything that you need in order to do asset streaming, so we might as well just move it out there and just like say that's what we're going to do. I think that's probably reasonable. And if we don't do all the asset streaming, that's fine, because at the moment we don't necessarily know if maybe there's going to be something other than bitmaps and sound files that we might have to stream in. But you know, as far as I'm concerned, like I think that's pretty much all of it. I think that's mostly everything that we would need to stream in. And so I feel like we can probably just go ahead and do that, right? We know we don't have any 3D assets because this is supposed to be a 2D game, and so pretty much loading bitmaps and sound files is probably most of what we would want to do. And in addition to that, we are trying to do mostly procedural animation, so it's highly unlikely that we're going to be doing something like streaming in animation files. Now, we may have some things that we want to access that are like structural, in case we want the game to support like you know, sort of mods or downloadable content or stuff where there's like some kind of package that comes in and that augments the game that doesn't actually change what's currently on the disk, that you just kind of add into it or something like this. So, you know, maybe we want to do something like that, maybe we don't, I don't know. But at the very least, we can put in the basic stuff of streaming in a pretty straightforward fashion. It's really not particularly difficult. So I am going to go ahead and start doing that. And what you can see actually at the moment, you can already kind of see that we've got a concept of asset streaming already kind of in place. The most important part of thinking about any asset system actually is kind of already in place just by what we wrote naturally, and it's kind of important to sort of sit there and go, oh, okay, I see what's going on, so I'm just going to mention it quickly. And that is that the primary sort of boundary layer in your game code that you have to worry about when you're thinking about how assets are loaded and managed is the place where the game code and the assets have to agree on the name of something, okay? And you can see that we've already done that here This code right here is the place where those names are essentially bound, right? You can see that our game talks about the grass bitmaps, the stone, the tuft, right, as these loaded bitmap things, and it's accessing them off of game state and saying grass. That's how it refers to wanting that grass bitmap or whatever. And here in the debug load bitmap, you can see that we have what the asset system essentially considers the name, which is a file, like a file path on disk, right? And so this is the code right here, the very simple code in terms of asset loading that we have right now, which is doing that binding. It's saying, here is a way to refer to actual data somewhere, and here is the name that the code is going to use to refer to that data, right? So that's what's going on at the moment. Now, what I want to emphasize here is that really all you need to do to have a reasonable asset streaming system is you need to make sure that the names that the game refers to are things that are always in scope, essentially, that cannot become invalid or crashable, right? Like a pointer could, for example. Like if you're referring to your assets by a pointer, you have a problem, because if you're streaming and you're pointing into something and that thing gets evicted, you've got problems, right? So, things like a pointer to memory, not a great way to refer to a particular asset. So you have that sort of thing to worry about. And the other thing that you have to think about is how those things get sort of resolved. Like how you can, how is the game going to be able to give it some kind of an identifier or a name and say, here's what I want. Here's the thing that I speak about, my semantics, what I'm trying to ask for, and you need to kind of go grab that thing. How is that, process sort of working? And so that's what we're going to start thinking about. What I want to do here is just point out that we kind of have a pretty simple sort of setup going, and we can almost see just from having written this usage code the sorts of things that we want to talk about here. You can see that we essentially have, if you will, three kinds of elements already happening, and they happen to be the three kinds of elements that I strongly suspect we will see over and over again. So even just from having written the code in the most obvious way, which again I always emphasize, just from having written the code in the most obvious way, we already see pretty much the sorts of stuff that we're probably going to need all throughout development. And that is, we're going to have an array of options for things, right? So an artist may specify some number of bitmaps that all correspond to the same logical ID in the program, right? Meaning the engine wants to think about grass. It has a way of referring to grass, and it needs to be able to know what are all of the options the artist has supplied in terms of grass right now, right? And you can see that we did our very simple, very basic implementation of this was just to have an array of bitmaps so that we know there are two grasses, and we said the two grasses came from these two files, right? So a very simple way of handling that, but again, a very important logical concept that is actually to carry forwards. It was not, the concept itself is not trivial. The concept is important and will carry straight through the development. It's just our implementation of it here that was simple because we were not at the point where we were thinking about asset loading. So that's a very important concept, right? The second concept, of course, which actually I guess I probably explained these in the opposite order, is just the concept of a basic bitmap, right, that we want to load. And so this is really an extension of that. It's saying that there are several options for that bitmap, right? And then the final thing we have is sort of the concept of a structured set of bitmaps. And if you can kind of remember back to when we did this hero bitmaps thing, the reason that we wanted to do that was because our hero had several facing directions, right? He had left, right, up, and down, and each of those facing directions actually had in it a set of bitmaps. They had a head, a cape, and a torso, right? And because there are several sets of bitmaps, we wanted to make it easy to have routines that animated these sets of bitmaps together without actually knowing which direction it was going to go, right? We wanted a thing that could draw a hero on the screen without knowing which direction it was talking about, and so we created a structure that allows it to do exactly that by having like head, cape, and torso here, right? So I think that is sort of very much so, with the exception of the fact that we don't have sound in here yet, which is something obviously that we have to work on. With the exception of the fact that we don't have sound in here yet, we've really seen pretty much exactly what we want out of the graphics system, at least at a fundamental level, in terms of how we're going to talk about assets in that respect. Okay. So what we can do now is we can say, how do we, again, sort of using the principles of incremental, compression-oriented programming, how do we take what we've already done and sort of build upon what we know we actually want in the code to do something that gives us that flexibility, but also allows us to trivially stream the assets in if we want to, right? And maybe while we're at it, maybe try to look for a couple opportunities to expand some things that were previously hard-coded into stuff that's a little more flexible, such as the engine not having to know, not having to hard code here that there are two grasses. Maybe it would be nice if we could say when it goes ahead and loads its resource pack, in at the beginning of the game or whatever, it just has a number of grasses in there, and however many grasses there are, that's how many the engine will use. And so that's another thing that would be something that would be nice sort of to keep an eye on as we go. Can we start to maybe remove some of the restrictions that just having typed it in as just straight C with nothing fancy going on, how can we maybe get rid of some of those restrictions or limitations that would sort of, as we go forward, that would potentially present themselves. So that's what I'm going to do. I'm just going to focus on that. And again, we want this to be able to work in the background, so I'm going to keep that in the back of my mind as we go. But the first thing that I want to do is really to take one small sort of compression step and to just move out the things that we were using into one place. And you'll sort of see why I want to do that as we kind of go forwards. But this is basically trying to get these out into a place where we're starting to think about the assets separate from everything else in the code. So here is all, all this stuff is not assets, right? These are not loaded. None of this stuff is loaded from disk, okay? But this stuff is, right? So you can imagine we had like a game assets structure here. And now I've got this game asset structure. I'm just going to go ahead and say we've got game assets down at the bottom, right? There we go. And all I'm going to do literally is just fix this thing where we've got, I've got to put assets.grass in there. That's literally all I'm going to do, right? It's the dumbest possible thing. Let's see here. Assets. Assets. So there we go. And these are all going to be assets as well, right? And again, I'm literally not doing anything here. There is no code change. I'm just slowly putting these, kind of into a more, a more isolated state. Just kind of really, really straightforward fashion there. Okay, let's go ahead and do that. And like so. Looks like we got a few more in here in the drawing routines. Okay. There we go. And oops, that's wrong. Okay. And again, this should, just run. It shouldn't do anything different than what it was doing before. It's all good. So now I've got these guys out here, right? Now what I want to do is I want to observe for a second that I want to start by taking the simplest of these assets, this backdrop, shadow, tree, sword, and stairwell. Because remember, these guys, I'm going to kind of break these up here, right? These are arrayed assets, right? And these are structured assets, right? Whereas these guys here don't have any structure to them. They are just a plain vanilla bitmap. So it makes sense for me to start with them first because they have the least amount of metadata associated with them, right? Yes, they're a bunch of bits, and yes, they have a little bit of metadata, which is like the width and height of the bitmap, for example, or what the sort of hot point is. So there's some, but there's only one sort of logical unit of rendering that the renderer looks at there, right? Is that just that one piece. So that is a lot easier than starting with something that has sort of a number of things or that has a structure to it where we know that it's got different components. So I'm going to start with the simplest one first and going to abstract away sort of some of the or I shouldn't say abstract away, but I'm going to kind of make it change its form, if you will. Okay. So what is the fundamental problem that I'm looking at here when I think about asset streaming and I look at what's right in front of me in terms of game assets? Okay, the thing there's essentially two things, right, that are problematic about what I'm looking at, I guess is the way I would say it. The first one is that you can see that like the data that I'm actually talking about all has to be here, right? Like I'm talking about this whole loaded bitmap and it's got its width and height and everything. It's all the space is reserved, essentially. And maybe, yeah, there's a pointer to memory in here, so I could set that pointer to 0, but I can't actually get rid of the whole bitmap itself. And if that could actually be an appreciable amount of memory. I'd like to maybe make that boiled down to something smaller, if you will, right? Or maybe boiled down to nothing at all, potentially. So there's that. The other thing that's obviously problematic about it is that anyone who's going to refer to this thing is going to refer directly to it, right? It's going to refer directly to, sort of the... It's going to directly access this particular piece of memory, which means that, of course, I don't really have any way of knowing who's using what, or whether or not something has to, whether something could be evicted. There's all sorts of things that are just problematic about that, right? So what I want to start doing is I want to start making it so that people are going to talk about these things in a slightly more indirect way, so that they could talk about them without ever necessarily knowing where they were or what they were. They could just use some kind of other name, right? So what I'm going to do first is I'm just going to introduce the simplest possible thing again. I want to introduce an ID that allows the game to talk about something like one of these guys, right? I want to be able to, maybe I'll say game asset ID or something like this. I want to have some way of referring to these things in here that do not actually, use the pointer of the thing that we're talking about. Okay. So I'm going to do something like this, where I've got my list of names that the game could use to talk about something. And then what I'm going to do here is I'm going to say, oh, I've just got an array of bitmaps now, and I've got this game asset ID. I know, oops, that's no good. I know I've got as many of those as there are IDs. I know I'm going to need that many of them if I want to implement this again exactly the same way, but just pulling out one more level. I'm just saying, okay, now you don't access it by the name that way, you access it in a slightly different way, right? And since I know that people are all going to be, accessing this as a pointer there, I'm going to say maybe we just have some way of saying that you get the bitmap, from the ID, right? So I say, pass me the game assets structure, and tell me which ID it is you're looking for, and I will go ahead and return that one to you, right? So that you don't exactly directly access out of it anymore. Again, because this is in preparation of the fact where there won't be anything to direct access, and so you will have to call through a function that actually does work. There'll be no way to directly do it. So I'm going to do it that way. I'm going to go ahead and return that there. Oops, did that wrong. There we go. So I'm going to go ahead and compile that. And, oh, and I forgot one other thing, I guess. I need a way to actually store these as well for the loading. But I guess I can just really, because it's returning me a pointer, I still probably could go ahead and do it by just doing it this way. In the future, that's gonna, we're not gonna care because the stuff's gonna get loaded in a different way, so that's fine. So I guess I can just do it this way, like so on, right? I suppose that will just work, right? GAI grass, what? Oh, wait, no, grasses should still be working just fine. So I'm looking at the wrong one here, sorry, that was my bad. Got a little ahead of myself there. We haven't gotten to that yet. So there we go. That will set the backdrop, or at least it should. And I gotta pass the address there. But I think that should give me essentially what I'm looking for this next step, right? And again, just trying to do some simple transformations to slowly move the code into a new sort of position that gives me a little more power than I had before. So, all right, let's take a look here. Got to put those ampersands in. There we go. And again, the same is going to go here. We've got that get bitmap, ampersand, GAI shadow, so that gets it there. And now we will do the same thing, get bitmap, assets, GAI tree, and same thing here, get bitmap, GAI shadow, and last one, GAI sword. Okay. A couple more down here. Let's see. And again, nothing strange going on here. I'm literally just translating these calls directly. I am not changing them in any way, and I'm not really even changing how the code's working at all. It's just going through a slightly more indirect route because we're sort of making a little, we're basically like sort of separating it out in preparation for putting something in between it, kind of thing, right? Okay, so that's all well and good, right? We've got those guys in there. And so now I'm able to talk about game assets by ID rather than by bitmap pointer if I want to, because I can always get the bitmap pointer out later, which is, you know, kind of one step there. But now I kind of have another question, which is like, oh, you know, what am I going to do for these other guys here, right? These sort of array assets and these structured assets in here where I've kind of got other stuff going on. Well, like I said, I don't really want to talk about those yet. I think that it might be a little premature to really kind of deal with those in any significant way. So what I'd like to do temporarily, again, this is just this is not how I want to deal with it at the end of the day, but so that we can make everything kind of flow through a little more appropriately, what I want to do here is I want to be able to refer. I want to be able to refer to those bitmaps so that they still have some kind of a slot. I'm trying to think of whether this is a good idea or not. You know what? I'm not going to do that yet. I'm going to wait. So, all right. Now that I have this, what I'm going to do is I'm going to just wait on those guys because I feel like it's probably just better for me to wait until I implement one of these. I think it's going to be clear explanation-wise as well. So we'll just put that aside. So what I want to do now is the push bitmap call. What I'd like to do with the push bitmap call is I'd like to make the push bitmap call actually take one of those, right? So we're going to do essentially the same thing that we have here in terms of what the bitmap takes in, right? It takes in this render group and the loaded bitmap stuff, right? And all we're going to do is we're going to change this to take a game asset ID, right? Like so on. And again, game asset ID is probably the wrong thing to use here, technically speaking, because we're probably going to want something that's like a bitmap ID, which is not exactly necessarily the same as a game asset ID. We'll see. But for right now, it's fine because we haven't actually made that distinction. So we'll sort of we'll expand that distinction when the time comes and not get ahead of ourselves, right? So what I'm going to do there is I'm going to go ahead and take that get bitmap code, and I'm just going to call it in here instead, right? And I'm going to assume that the render group has been set up so that it has a specific place where it expects assets to come from, right? So we're going to say, all right, we've got an asset pointer that's in the render group. We're going to ask for the bitmap that corresponds to a particular ID, and we're going to, sort of go forwards with that, right? And I guess I'm gonna, I'm also gonna maybe pull it out here just so I can do it this way, like so. There we go. Okay. And we do this bitmap loading. We get look at the assets. We got the ID there. That all looks good. And trying to think if there's anything else that I care about here. No, that looks about right. So once we get that bitmap back, then we're all good, and you can call this function just fine. So what I need to do, again, to make that work is I need to look at the render group, right? And I need to make sure that the render group has a notion of who it gets its game assets from, right? So when you're rendering any particular, there we go, any particular render group knows who it's going to ask for assets. That will be something that when you when you allocate a render group, you are required to pass in, right? So game assets, assets, like so. You have to pass those in. That's just a flat requirement. Yeah, I think that will do it. I just have to actually store it here, like so. There we go. Okay. So if I go ahead and compile that, looks like that's not a known thing at the time. That's fine. There we go. And I need to pass it here. I also don't know if it should really be in the game state. I feel like it's kind of a transient thing. To be honest, now it's going to be transient because it's going to fluctuate. So I feel like game assets, to be completely honest with you, is actually something that should probably be in the transient pool. So I'm going to go ahead and stick it in there. Okay. So in here, when we allocate the render group, we're going to pass the trans state assets along with it. There we go. And all of these guys for game state assets, they're all going to take trans state assets, like so. There we go. Load those in there, and so on. And of course, we have to actually, if we're doing that loading, we have to do that out where we can actually make that stuff be in the transient state. So I'm going to grab this out here. I don't think there's any real dependencies on that anywhere, but I can come in here, and then after we've sort of done the ground chunk stuff, I can put that in there. And in theory, that's all going to be totally fine, and nothing weird will happen. Hopefully, that's, famous last words, right? Famous last words. So here we go. We're working just fine, loading as expected. So now I'm going to go ahead and in those push bitmap calls, in the ones where I can, I'm going to go ahead and make all of the push bitmap calls actually just use those bitmap IDs if possible, right? So anywhere that can use a bitmap ID, it will. So you can see that we were previously calling get bitmap here. Instead, I'm just going to call, I'm just going to render with the actual ID that I was trying to use to render this thing, right? And so there we go, like so. Again, this is really, really straightforward. I'm just moving it slowly, one step at a time, down into sort of the renderer doing that query. And again, no big surprises. Games looks the same. Everything is loaded as we would expect. Okay, so now we have the renderer is actually the one who's talking about these assets, and the important part about that, and the reason that I am sort of bringing it to your attention, or rather that I am sort of doing these slow things so you can see, how they go and see each individual step of the process, is that what we have now done, and this is a very crucial step, in my opinion, to doing background streaming properly, because a lot of people say background streaming is really hard. And I don't really know why that is. I've never found it to be difficult. I've always thought it's very straightforward. And so I feel like it's important to kind of go through all of the steps and just show how they work and how they logically follow from each other, just to clear up whatever the confusion is about background streaming. So anyway, so what we've done here now, right, is we've put ourselves in a position where the renderer is getting an asset ID, and it's asking the asset storage to give it back the bitmap for that ID. What we can now do is say, if for some reason that bitmap was not available, we can just not draw it, right? So we get rid of one of the critical failure cases, which is that somebody goes to render something and they have a pointer into some invalid data, or worst case, or whatever. And we also get rid of the problem of, oh, we're trying to render something and maybe it's off screen, but we don't know that. And then we end up in a situation where we're trying to render something that hasn't been streamed in yet, and it causes this problem and locks up the frame because it's waiting for that or whatever. We can actually just get rid of all of that and say, look, when we try to render something, if it's not there, we just don't render, right? And in my mind, that's actually always the right decision because, you know, your game should be set up so that the streaming is always ahead. If the streaming ever falls behind, I would rather not have the frame rate take a hit. I mean, as far as I'm concerned, that's just a bug because the frame rate shouldn't slow down. There are ways that we can make it so that the frame rate does stall by basically here, if the bitmap's not there, you basically say, oh, you know, go ahead and stall the frame. But I usually just do it this way, and I just say, okay, we always make sure that the streaming system is fast enough to keep up, and if for some reason it doesn't keep up, the worst is you'll get some kind of flicker where a bitmap that was supposed to be loaded wasn't loaded. And there's other things we can do to mitigate that by using fallback bitmaps as well, and so on. But yeah. So now we've got a situation where we could just not return something if we haven't loaded it, right? We could just full on return 0 and the renderer just won't render it, right? No big deal. What that means is I can now go up here to my game assets, and what I can do is I can change it so that actually now we don't necessarily have all of them loaded. Right, there's maybe we don't have them loaded. We just have a pointer, and that pointer is going to be null when we start out because there are no bitmaps yet, and off you go, right? And so what would happen there if we were to do that is when we do this here, right? We would actually grab out the pointer, and the pointer may be null, and that's fine, and we return it. Okay. So I feel like now, I mean, this will still work just fine, right? Oh no, it won't because we haven't actually allocated space for those guys yet. So we need at least some kind of a little debug loading guy here. All right, so I'm going to grab these guys here. All of the things that were in the assets, these are the guys that are in the assets, right? I'm going to grab them up, and I'm going to put them in a separate routine here. Right? This routine is called, you know, load assets or something. I don't know. Pick your favorite name for it. And what that's going to do here, this is going to take game assets structure, and it's going to go ahead and do the loading. But again, what we do now when we do debug load bitmap, what that actually does is that gives us back a bitmap structure. We haven't actually allocated space to store any of these, so that's a little bit of a problem. Oh, whoops, I grabbed the wrong guys. My bad. Sorry about that. Put that back. Nobody saw me. Let's just pretend that never happened. All right. So if I go in here and I just sort of clean this up a little bit, right, the only thing that we would need to do here is we need to figure out, again, some way that we can make these guys allocate actual storage space. And that's not particularly difficult, right? in debug load bitmap, when we're calling it here, I could just go ahead and allocate the extra space for the bitmap by making sort of a temporary routine here, which is like, you know, allocate or debug allocate load bitmap, something like this. Let's go ahead and put those in there. Allocate load bitmap, allocate load bitmap, allocate load bitmap. And what this will do is this will take the transient state so that it can go ahead and allocate space for bitmaps as it loads them. Okay, so there's the trans state, and off we go. So we've got that in there. This function is just going to call debug load bitmap. It's going to pass all of the same stuff that it got right in here. Line X, top down line Y. And all I'm going to do is I'm going to take that transient state and I'm going to use the transient arena to basically get ourselves some space for that bitmap structure, right? So I've got loaded bitmap like so. Okay, I've got my loaded bitmap that I'm going to allocate here, and I essentially want that to go, let's put this, we'll do a little result here, and I guess also this will just return a pointer. We're not actually even going to have to do this call anymore, right? This is just going to be assets bitmaps. There we go. Oops. Text transformation. Just enough to be annoying, but not enough to try and wrestle with an Emacs macro. You know how it is. All right, so when I do that, I'm going to try to allocate one of these bitmaps here by getting it off of the transient arena. I'll, take a loaded bitmap, and that'll be fine. I'm then going to try and do the debug load bitmap call. I have the result that I want, so that's I'm going to write. I'm going to write into that with debug load bitmap whatever comes back, and then I'm going to return the result, right? What did I do wrong? Loaded bitmap illegal use of the type of expression is push size. Not the right function. It's push struct. That's what it is. There we go. I don't know what the name of this arena is, actually. I guess it's Tran Arena, so that's fine. And the thread, when we call load assets, I guess I have to pass that. I guess I have to actually pass both of these, unfortunately. So we'll go ahead and put those on there. And then I think we should be good. Memory. Oh, right. So this can just be read entire file. Go. Read entire file. And there we go. All right, hopefully not too many more little things to do. There we go. And it does not take 4 arguments. That is true. I guess there's a default parameter on those guys. Debug, or maybe not. 1, 2, 3. So if there's no default parameter, what was test background previously using? Is there one with? No, there it is, right there. So it's actually doing these guys here. Yeah, it's using 0.5, and 0.5 is the align percentage in the case where nothing was specified. That's frustrating, but that's okay. Again, this is only a temporary routine, so we'll just spam it for now. That's totally fine. Not what I would prefer, but it works. All right. So now we should see nothing, right, in the places where there are where we're going through that path, because we've never called that loading function, right? So we're never going to see those, okay? And we don't, and that's correct. And now if we actually call the load assets function, we should see them show up, right? So here we go. There's that trans state with the assets and thread context, and I saved this here because I never remember what it is. There it is. That read entire file. Okay. Oops. Load assets cannot argument 2. That's true. That needs an ampersand. And so now those guys should be loaded and show up, and they do, which is what we would have expected, and that's good. So we've got our trees back and so on, and our shadow and all that other good stuff. All right. So now that we've got those assets loading this way, what we can also do now, right, is we can make those assets if we want to. We don't actually have to load those assets until somebody actually asks for them, right? We're now sort of in a position to actually start implementing a little bit of that delayed loading, if we so chose. So the question is, how would we go about doing that, right? And here's the part where we probably want to start getting into the operating system stuff, because we would like to be able to queue up the disk reads, but we can sort of simulate that, because since we actually do have a task system now, we can kind of put that, we can kind of use that a little bit. I just want to emphasize the fact that at least at the moment, it's not really the case that we want to necessarily use the task system and let it block for some reasons that I'll talk about a little bit later. But we can start by doing it that way, and then maybe go into the OS layer and add some additional support that we're going to want for doing loading in a smarter way than this way. So what are some things to think about here? So when we're doing load assets, right, we're loading all these assets at once. What I'd like to do now instead is have a way, have a function that just loads an asset. And again, this is going to be probably like one of the dumbest things that you've ever seen, but we're still, again, like I said, one step at a time. Very, very important to do one step at a time. And so that's what we're going to do, right? I'm literally just going to wrap this in a switch statement so that we're literally calling the exact same code. We're not doing anything else, one step at a time. So we're wrapping it in a switch statement. And so now we know we can load just one of these. And again, the only thing that's changing here is that the switch statement makes it so that it only calls one instead of calling them all in a row, right? So what I want to do here is say, all right, we're going to call load assets. And instead, it's just going to be load asset, right? And it's going to take in here some ID, right? It's going to take a game asset ID. There's the ID. And it's going to load it, right? So this call goes away now. Again, if we don't do anything, since we're never calling that function, we don't see anything at all. But if we go back in here now, we can opt to actually make that call at various times if we so chose. It's a little bit, what we probably want to do, because it's a little bit gnarly to actually call, is we would like to be able to have our load asset call actually do something, you know, maybe it keeps a couple of these things kind of a little more understood so that it doesn't have to have them all passed in all the time, right? Especially because we're not really going to be calling this debug allocate load BMP thing. So it kind of just gets annoying to pass all these things in here when we're going to probably go ahead and get rid of this and switch to something that we can use a queue for, right? Okay. So let's see. What do we want to do here? I guess what I'd like to do is say, well, when we call in here, I guess we will pass maybe the transient state, we'll pass the game assets, thread context, yeah. So for the next step, I have two choices, and I'm not sure which one I want to do. Choice one is to have the renderer directly request assets to be loaded. And number two is to have them go into a queue to be loaded later. I think what I would like to do is probably, I think I would like to make it so that the render requests assets directly. Even though that's a little less clean, I would say that eventually I feel like we're going to be in a situation where certain background render processes are going to have to block on assets that they need loaded in order to do compositing properly. And so I think we're going to want the renderer to be able to force that issue, if that makes sense. Although we could force the issue from outside. Man, that's a tough one. That's a tough one. Well, I guess I'll just have to experiment a little bit and see. But anyway, for the time being, let's try to make a little bit of forward progress there. We only have about 10 minutes left on the stream anyway, so let's just keep going with where we were. And as we sort of root around in there a little bit more, hopefully it'll become clear what the correct choice is for that particular thing. So let's say we were taking one of these guys and we were going to do this push bitmap call, right? And this push bitmap call again needs the game asset system needs to be able to do this stuff. The only thing that I'm not crazy about is this thread context thing here. And so I think I'm just going to go ahead and just cheat about that, because I really, like I said, don't want this guy to ever be talking about a thread. I don't want him to know about a thread. I don't want any of that stuff happening in there. But because of the way we set up our debug allocate load bitmap, it takes it just as a dummy, which probably was a stupid idea. But, sometimes you have stupid ideas. So anyway, I'm going to go ahead and say that we've got an arena in here, in a game asset arena. So this is going to be a memory arena, asset arena, and that's where it's going to get its assets from. So it's going to get rid of the trans state, and it's going to, instead of passing trans state here, it's just going to pass an arena directly. So it'll pass a memory arena. Here's the arena, like so on. There we go. And so this will just pass that arena directly through. There we go. We will store a read entire file for now in here, so that that's in there as well. And that way that goes away. And then thread, we're basically just going to put to 0 to do get rid of this thread thing when I load through a queue instead of the debug call, right? So anyway, we've got our game assets here, and we've got the ID. So now it only needs those two things, which is what I wanted. It goes ahead and passes, I guess we'll just say this is the arena. We know it's the assets arena because it's in the asset structure. So we'll go ahead and make all that happen. There we go. And continue on. Assets arena. And read entire file. I'll just deref it out here. Assets, read entire file. And now I would like to compile. There we go. And when I set up that game asset structure at the beginning, now I have to actually do it. I have to actually get that stuff initialized, since right now it's not set to anything, right? And so inside our transient state initialization here, I need to do game assets. So, oops, I guess I should do it probably up a little higher, huh? When we initialize this stuff, I'm going to go ahead and say that we have our game assets has an arena, and that arena is a sub-arena, like so, of the trans state tran arena. And that's going to be, at the moment, this is going to be eventually our biggest thing, because it's going to store all of the assets that are loaded. But at the moment, we will not actually be doing that. So I'll keep it a little conservative here, but eventually we'll make that pretty large. So we put that in there. And then we need to set up read entire file as well. Oops, that should be trans state assets dot read entire file equals memory debug read entire file, platform read entire file. And that's the only things I think we had to set up. Okay, so now it's as simple as just calling that load assets, right? That load asset function. And so if I want to do this now, even though it's synchronous inside render group, I can go ahead and say, you know, if the bitmap isn't in there, well, that's okay. Why don't you just go ahead and tell somebody to go get it, right? So that it'll be there next time, right? And that seems like a good idea. Load asset now needs to be something that can be called externally. There we go. And so now, in theory, when we run stuff, stuff gets loaded, right? And off we go. Okay, so furthermore, we can even probably now, if we really want to, and we're not quite in the full position to do so yet, but if we want to, we could probably now even make this be a background loaded thing, right? What we could do here is we could say, okay, if we want to background load this, remember how we did our background stuff for, say, doing the ground chunks, right? We had something that looked like this. And so what we could do is we could say, you know, we have a thing called load asset work. And the load, 5-minute warning. The load asset work is just going to take the stuff that this thing needs to actually do stuff. Okay? So it's going to need the ID, it's going to need the asset structure, it's going to need that fake thread, right? Which, like I said, will need to go away. It'll need read entire file, but it can get that just out of here. And then it's going to need the file name of the thing that it's supposed to load, right? So I think that's almost everything that it would need there. So if I went ahead and said that we had load asset work, and I grab that out, then as long as I have, I think really all I need is assets and the file name, right? So it'd really just be that, I think. Oh, and the ID. Right? I think that's it. And that would be just about everything, right? So we'd have the game assets pointer. We would have the file name, and we would have the game asset ID. So if we wanted to then fill ground chunk work, we can look at how that was happening here, right? We have a little bit more work to do to actually get it out there. Load asset. We would need it to do something where it actually gets a struct to fill out the work order, and then actually does a platform add entry on it, like so. And that would need that that priority queue. I'd put that in there, or the asset load queue, something like this. And this would use that load asset work function. So there's load asset work. There's the work order. There's the queue that it would use. And what I want to do here is say, again, we need to do that sort of begin task with memory thing. So if we're going to do a begin task with memory, like so, then if I remember correctly, the task has its own arena. So we can go ahead and grab that in here. There's nothing special we have to do there. The work order for this guy is assets file name, right? So it's assets file name, and that'll actually be what's handled here, right? So assets file name. Like so. Keep it going. Almost there. Again, just not quite enough to make an Emacs macro out of it, but just a little more than is fun to type in. What are you going to do? maybe Mr. Fourth Dimension will finish his editor and it will fix all these things. Who knows? You never know. All right, so we need to specify the rest of the stuff here. We got task. What was the other thing that we needed there? Oh, the ID, right? So there's the ID. So if we go ahead and do that, now technically when we go ahead and do this debug allocate stuff, that'll happen on the separate thread. The only thing that we don't really, that's not particularly good about that, and you can kind of see it happening here, is that if we do this, we put ourselves in a position where, oh, you know what? I lied. There are a couple other things we need here. There's the alignment stuff. So not quite. We need the alignment. So we need work file name equals, there we go. But we also need these guys, right? Work, oops. So now it maybe would have been good for an Emacs macro. Let's see, work file name. So I'm not going to worry about those just yet, but I want to leave them here since we did the work of actually figuring out what they were, right? I don't want to delete those. So otherwise, we just have to go look at a previous version to get them back, and that's no fun. For those of you who use source code control, you know how annoying that is. Oops. Oh, so that one doesn't have it, I guess. All right. Well, I guess that's another one that does not have any kind of centering to it. This one does, though. There we go. So that's really all we need to do to get that job spawn. The only thing that's a little nasty about this that I don't like, right? Oh, and of course I got to fix this part right here. Work ID equals ID. Work task equals task. Work file name equals nothing until it gets set. So the only thing that's a little bit annoying there is I don't actually want this guy to be playing with the transient arena while he's working. That's no good. I don't like that at all. So what I would rather do here is I would rather have him do something where he does not actually take the arena. I'd rather have the loaded bitmap result thing happen outside, right? I'd rather have it happen here where we do like the bitmap and we do that push struct. I'd rather have it happen here where it does assets arena here, because that way nobody is touching that asset arena multi-threaded, because right now we don't actually have any kind of synchronization happening with that arena, so I want to make sure that only one thread can ever touch it at once, and that's not really too much of a big deal. And that also means I can get rid of the other thing that I was doing here. That can go away, which is I can go ahead and make this guy actually just take that bitmap and write to it directly, right? So it'll write to the bitmap directly, and then once it's done writing to the bitmap directly, I'm also going to make a little to-do here, fence. Then we can go ahead and say, oh, whatever the assets are, now go ahead and make sure that they point to that bitmap. Right? So that's all we really need to do there. And these guys now, I believe, go away because we can just call debug load bitmap directly on them, right? Just by taking the thread, entire file, and the work file name. Now we have to pass that align x, align y eventually. So again, that'll be our task for tomorrow. I'm not going to do it now. But now I'm just going to go through and clean up, and then we'll call it a day. So loaded bitmap, there's bitmap. Begin task memory trans state. Do we have a trans state here? I guess in order to begin a task, we need the trans state. So I suppose that kind of puts us in a position where it seems kind of clear that the game assets kind of need access to that trans state. Kind of annoying. It's nice to not have to do that, but what are you going to do, right? So we have our transient state here. I'm just going to add it in there, and we'll make that happen like that. So we've got assets, game assets, not that's because that's not what I was trying to do. I wanted a load asset work. There we go, load asset work. Push size needs to take the arena there. And the asset load queue, I guess, is not such a big deal anymore because we can just now use the low priority queue for that. And then finally, down here where I do the trans state asset stuff, which is right here, I'm going to go ahead and make it so that it has a pointer back to trans state. Not thrilled about that. We'll have to think about that. To do Casey, not thrilled about this back pointer, but that's okay. It's not going to cause us any real grief. All right, so this probably won't work because we slammed a lot of stuff in there at once, or it just will work. So hey, guess what? We background load now, and happy birthday. So now all of our art assets are streaming. There's a bunch of stuff we haven't done yet. As you can tell, people are in the wrong position because we haven't passed their alignments through, but that's just a little bit more typing that I have to go and do. There you go. Asset streaming in an hour. So really all we have to do, there's really not that much more to it. Really that's most of it. But we have some things with resource reuse that we have to worry about. There's some things in there that are kind of tricky, so we've got a little bit more to do. But for now, we'll go ahead and go to the Q&A here, so we can make that happen. All right, so anyone has a question, please prefix it with Q:, and try to keep the questions to stuff that we just did. There's a ton of stuff I just did there with asset streaming. If you have questions, now is a good time to ask them. Robbie says, is it useful when assets can be modified from outside, file on disk overwrite, maybe even in memory, and still work in game? Is it now supported after an asset is loaded, as I could not see any callback to check if a file is modified, as your glazing speed refactoring was way too fast for me? So no, we have not added that yet. I think you're referring to kind of hot loading, right? That's obviously very easy to add in a system like this. The way that you do that is you just have a secondary check that goes through periodically and looks at dates. You just store the dates of things, and then you reload them if you want. We are probably never going to implement that here because all of our art comes from an artist. And the artist isn't running the game, and in fact the artist can't run the game because there isn't a game yet, and so she makes them before we actually have a game running. Now maybe we should add that sometime just for fun, but we don't actually have any use for that feature, so we probably won't implement it till much later if we implement it at all. That's just the nature of it. If this were a different type of game where I was actually able to work 40 hours a week on it, as opposed to having to wait to do it in an hour-long chunks on a stream, I would absolutely implement the feature you're talking about because it doesn't take very long to do, and then it helps the artist to do it. But because the programming is so slow on this game, because it can only go 1 hour a night, she's probably has to do a lot of art assets without actually playing the game, if that makes sense. In load asset work, where is the memory for the file name stored? It is not. There is no memory used for the file names in addition to just the string constants. So those string constants are just they're just being used in C++, right? They're stored in the executable, and they get loaded in as part of the executable, and they get used as part of the executable. So there is no storage for that. These will go away eventually because once we have an asset pack, there won't really be file names anymore. So even if we did have to store space for them, you wouldn't really have to think about it too much. If you wanted to store them anyway, it'd be pretty easy to do so. What you would do here is you just have the file name right here. You just push it onto the task arena. So, in fact, I'll just do that for you so you can see, right? We have a task arena, which is just a little area that's scratch space for the task. So if you wanted to, you could really trivially just go ahead and do that, right? That's all you'd have to do. And that push string would just be a thing that copies a string on there. But we don't have to really care about that at the moment. If we were going to leave those in there long term, I might do what I just did permanently. just for the sake of our code hot reload, because those strings will move, and so if there's a background task loading an asset, that string would move and that would cause a problem. But since we're not going to leave those strings in long term, that's just not a case we care about fixing. What are the trade-offs to give him more power forcing render pushes out of the rendering queue order? I do not understand the question, sorry. You said we got asset streaming done in an hour, but do we need to do multiple passes on it? If so, why? Yeah, so when I said asset streaming in an hour, I'm just kind of being flippant. I don't consider us done. All we did was the first part of asset streaming, which is to actually get our assets loading deferred, right? But there's a bunch of things we want to do, which is how do assets get evicted so that if we want to run in a fixed amount of memory, like right now, we can only run if there's enough memory for all the assets in the game. But I feel like it would be more appropriate for us to be able to just set a memory budget, like say this game runs in 256 megabytes of memory or a gigabyte of memory or whatever, and then the asset streaming just goes ahead and uses that size and evicts things when it needs to, right? There's that. And then there's also the fact that I was saying I want to go ahead and tackle these guys as well, so that we can have ways of streaming in more complex objects. So basically, like, the basic streaming stuff is done, but I want to do more. There's more things that I want to add features, right? I don't, that's not all that I want out of an asset system. I want additional features. Where you check if an asset is already loaded or not. If an asset would take a very long time to load, would it check if it's loaded again to try to load the asset again? Not sure if that makes sense. Yes. So there's a couple of things again that we're not that we're also not doing at all here in any smart kind of way, right? Which is that when you call load asset, we don't mark that asset as already being sort of loaded. To give you a preview of what we're going to do tomorrow, excuse me, we will probably do something like, asset state or something, right? And the loaded bitmap will go in here, right? And, it's queued or something. There'll be like a thing in here. Well, it'll actually be, it'd probably be more like this, asset handle or something like this, right? Right? And so what will actually happen is that when it goes to load an asset, it'll elevate the asset handle to mark it as being queued so that other people won't launch another task to load it. Because you're right, it'll just try to load it again and you could fire off multiple tasks. Right now we're kind of saved by the fact that we have a very small number of people in our work queue. So it doesn't immediately cause this disastrous problem of like, hey, we're trying to load 32 trees and we're trying to draw 32 trees and we loaded the tree 32 times. But yes, that's exactly the way that we will do that. Hold on a second, let me make sure. Yeah, so I didn't want to make sure that I left the code in a compiling state. Do you consider terrain an asset too so that it can stream? Well, our terrain is dynamically generated, so I mean, it's a kind of a separate, it's not loaded in that way. Constantinople asks about just the way that I structure my ifs. He was saying, why do it this way instead of just doing it this way, right? Same basic idea, right? The reason that I never, ever, ever, ever write code that way, I think you have probably seen me do a lot of coding now, and you've never seen me do that. The reason is because I always like to have a clear exit point from a function. so that if I have things I want to add to the function when it is done, I know that they always will happen. And I don't have to worry about if someone put a little bungee pit in here to thwart me by returning out from the middle and it won't happen, right? So I never, ever, ever use that other format. Let's see. What are the trade-offs to give the rendering queue more power, forcing render pushes out of the render queue order when it is multi-threaded, so the rendering can be controlled more fine? Okay. I think I understand what the question is now. So I'll answer the question I think you're asking because it's a good question. If this isn't the question, please rephrase it one more time and we'll see if I can get it that time. What I think you're saying is, okay, we have threads, right? And those threads are doing work. But there's a lot of different work to do. For example, there's threads that are rendering the game. So they're trying to make the images that we're using, right? We have the rendering threaded. There are threads that are doing background work, like composing ground tiles, and now asset loading. And so the question is like, what are we going to do to like balance that? And like, what can the render queue? Can we have the render queue maybe take threads when it needs them to get more rendering power, or whatever? And so my answer to that is, I don't know that. I don't really know that there's all that much we really want to do there, because at the end of the day, you know, the performance of the renderer seems pretty good. I don't know that it has to do a lot of work stealing. And when we want, if we really find ourselves in a position where we need that performance boost, we have the GPU, right? We aren't even using the GPU yet in the system because our software renderer was so darn fast. And so, you know, I think maybe it would be better to concentrate our task stuff on not on having the renderer be something that steals tasks. I think that may just be kind of a waste of time. Even though if we were going to target software rendering as our primary shipping platform, maybe that would make sense. So I don't know. I don't really have a lot more thoughts on it at the moment, beyond what I said previously on other streams. How much of the DirectX OpenGL typical pipeline are you preemptively designing into your code now? None, actually. If for no other reason that no one's going to be programming DirectX or OpenGL in a year, right? They're all going to be using Vulkan, D3, D12, or Metal, right? So the DirectX OpenGL typical pipeline is gone. It's out in the back waiting to be put down. Any other questions that are on topic? I will answer some off-topic ones here that I see. If no one has any, I don't see any other on-topic ones. So I'll answer. There were a couple of programming questions on here that were not on topic. So somebody said, "What do you think about Microsoft's vector call as a calling convention for speed?" I don't think I've looked at vector call specifically. But I am happy to do so. What is that calling convention? Hello? Okay. Vector call calling convention specifies the artist to functions are used to pass registers when possible. Well, yeah, I mean, that's fine. So all this is normally the x64 calling convention already specifies that arguments are passed in registers, but only up to a point. And so really it's about the trade-off between leaving registers free and you know, whether you have to save and restore them and stuff like that. I usually find that this sort of stuff is just not that interesting, right? Like, why are you making so many function calls that this is going to be a big deal is usually my thinking, right? If it's really a big deal that you're calling functions that often that you got to worry about the calling convention, I usually feel like maybe that code was not structured properly, right? Now that's not to say that there aren't circumstances where it could be true. So I'm not trying to say that if you use vector call, you're stupid or something. That's not true. I'm just trying to say that my first thought on things like vector call is that like usually those tend to be patch ups for situations that probably you shouldn't have got yourself into in the first place and the code should be restructured. That said, like anything else, if you look at the code and you've determined that the problem is stack pushes and pops, and that's why it's slow, hey, vector call may help you, right? You know, so yeah, but not a lot. Oops, not a lot to say about that. It's kind of an old concept. It's been around for a while. Is it possible for the OS to lose track of memory that you ask for? I guess I'm not sure how to answer that question. What I would say is that obviously if the operating system has a bug, it could fill out the memory, like the page tables, and then when your process gets swapped in, it would have the wrong address layout. That's certainly possible. I mean, but if that was the case, you know, everything would crash. I mean, there's nothing you can do about it, right? I mean, that's just a straight up bug, and it's game over at that point. Could you elaborate on OpenGL and DirectX death? Well, I mean, there's not a lot to say about it other than the fact that the models that DirectX and OpenGL were using were just somewhat antiquated in terms of how they mapped to hardware. They were they're too based on setting individual pieces of state and not in sort of having those things be more structured the way the card actually thinks about them. And so the reason that Vulkan and Direct3D 12 have to happen, and you know they're kind of based off of what was happening with Mantle, and then Metal same way, is just because they're trying to realign how you talk to graphics cards to be more like what the graphics card actually needs to do. And that way you eliminate just a huge amount of overhead that drivers were previously doing to turn OpenGL and DirectX calls into the actual stuff that the graphics card accepts, right? So. Looks like that is the end of the questions, maybe. What would be a good way to expand asset streaming to support increasing level of details? What I'm thinking of is loading a smaller version of the asset first and then bigger size resources. If you're doing that, then what you need to, I can sort of explain that here. So hopefully what you can see what we're going towards here, like what we did today, you can kind of extrapolate outwards how this is going to go. We won't really be dealing with the level of detail thing because we're a 2D game, so level of detail doesn't make a whole lot of sense. But in a 3D game, you would have this situation. There are actually times that it does make sense in 2D, but I won't go into those. So anyway, when you take a look at what's happening here, essentially you have people talking about a game asset as just an ID. And so if you wanted to update this to be more about getting a particular level of detail, you would just need to upgrade this notion so that the asset handle, right, would also know what level of detail it was loaded at. And then when the renderer goes to render, it would say what level of detail it was wanted based on the size that the bitmap was being drawn on the screen. And then the game asset would go, oh, is that the level of detail I'm at? If yes, just return it. If no, then queue up a load for the higher level detail, and if I have a lower level detail, return that, right? So it's really pretty straightforward. Like, there's not a whole lot to it. Hopefully you can see how that would go. So I recently started from the beginning of the series on 13 at the moment. Do you suggest watching all of the Q&As or just going episode to episode? I mean, I think it probably depends on how well you understood all the episodes. If you feel like you totally understood all 13 episodes, you probably don't need the Q&As. Because most of the time what people ask about in the Q&As is something that happened on that episode or previous episodes. And so while there is good information in those Q&As, that if you have the time to watch them, you probably would learn some things maybe. Because people sometimes ask questions that are sort of tangential, like the person who just asked about level of detail, right? So that's good. But if you feel like you have a really solid understanding of what I did, then just in terms of being able to program Handmade Hero, you probably don't need the Q&As because the stuff that's going to be about programming Handmade Hero in there is you've already got it, right? But if you feel like you're a little shaky, then I'd say watch the Q&A because people probably asked the questions that you have, right? So, and I'll take one last question here because it's kind of funny. How infuriating is it to deal with massive asset pipelines dealing with dozens of pieces of software on large AAA project? Absolutely infuriating. It's just awful. And because invariably these pieces of software are incredibly unwieldy and have all sorts of problems with them, and they don't support running in an easy way, and they come with all this digital rights management nonsense. So like the build machine can't run the thing unless the license server is on there, but like it's a Linux machine and they don't ship the thing for that, or like there's just all these really awful things that happen when you bring software into your pipeline that you didn't write. Like not invented here, there's a reason for it. And it's because nowadays the software that you buy is by and large awful and is really hard to deal with, and comes with a bunch of restrictions that are hard to work around. And yeah, it's awful. So you're right. The answer is very infuriating, and I try to keep that stuff to a minimum now. On the current project, we use Photoshop. On their next project, I'm hoping very much to eliminate it because it just causes headaches like everything else. Fortunately, with Photoshop, you can read its files directly, so that gets you out of the business of having to do exporter plugins and stuff like that. For 3D software, you're often not so lucky. For 3D software, oftentimes you have to write an exporter that's like welded into that version of the software, and when that version of the software upgrades, you got to redo your export plugins, and it's just awful. So yeah. So large AAA projects, those devs go through a lot of crap. I mean, they wade through a lot of crap for you to be able to play those games, and yeah, it's not fun. It is not fun. All right, looks like we're just about out of time, so let's go ahead and call it a day. Let's go ahead and call it a day. That was pretty good work today. Background asset streaming in an hour, not bad. Got more work to do on it, but hey, that's gonna be, I don't know, a couple days, and we'll have that whole to-do item just gone, right? It's just out. So hey, a lot easier than the render, right? And again, this is why I say I don't understand why people say it makes your architecture weird or that it's hard or any stuff. I have no idea. Like, asset streaming has always been something that you just do, and it takes, a couple hours of work, and then, maybe there's some debugging at some point, but it's like asset streaming is trivial. And yeah, if there's someone out there who knows why it's supposedly hard, I don't know. Maybe it's because you just got too much of a pointer festival happening, or I don't know. But anyway, so hopefully that's good. We got a little more work to do, so it's not as easy as I made it look today, because we do have some other things that we got to do, so it's a little more complicated than that. There's a few more hours that we want to put into it, and so if you'd like to see those, please come back tomorrow, 5 p.m. Pacific Daylight Time. I'd love to see you here. and I will show you the other parts that we got to do to kind of make it a little bit more of a real system. All right. As always, if you would like to follow along at home, you can pre-order the game on handmadehero.org. You can pre-order with this handy little pre-order button, and it comes with all the source code so you can play around with it at home. I upload it every night after I'm done, so you're always current. We also have a forum, so you can go ask questions, view the episode guide with annotations. You can get ports to Mac and Linux that community members have done if you're trying to do that. We also have a Patreon page. You can support the video series if you like what you saw. We're always very much appreciated for people who subscribe to the Patreon. It's a super nice thing for you to do. And we also have the tweet bot, which tweets the schedule at you. So if you're trying to catch this live and you want to know what the schedule is going to be in advance, that's the place to do it. That's about it. Thank you very much for joining me for another episode of Handmade Hero. It's a pleasure coding with you as always, and I hope to see you all back here tomorrow. Take it easy, everyone.